Okay, folks, I want to start off talking as we look at kites um, with sort of the idea of here's a little rudimentary, maybe look of a kite. Let's say we have these. Now, you should have by now talked about the different parts like the bridle, the frame, the sail, the line, all of that. But what I want to talk about in particular is in order for our kites to fly and to move around, they must experience something called thrust. Somehow they have to be moved through the air, sort of like our rockets did. So when we did rockets, we have rockets that experience thrust. Where did the thrust come from? Well, the chemicals inside the rocket motor they expanded dramatically as they burned, and they were forced out, and so that pushing of one way propelled the rocket the other way. So it's completely different than what we're talking about here. So, where does the the kite get its thrust? So, in order to understand this, we need to understand really two things. One is like your standard idea of thrust. So, thrust would be moving the kite forward that way, right? So, thrust would be pulling the kite through the air. Um, so that original notion comes from if you're down here, let's say you're down here and you have a hold of the string, there are times when you want to get the kite going, or you're beginning your the idea here, you're getting things started, that you are, say, running in this direction in order to get the kite um, the thrust that it needs to get started, maybe to get up into the wind stream and get some other type of thrust. So there is that idea of thrust that's coming from us pushing that way on the kite, okay, or pulling on the string or the line, which is pulling the kite that way. Now, here's the other part of that that is sort of, I think, less well known. And I'm going to delete some of these things out of here so you can see this better. Um, okay, I'm going to go back to put my guy in here. So the kite, the thrust on the kite is, in this case, moving this way, the direction of the arrows. But let's imagine for a second that I'm going to use this sky blue or very light blue for the direction or movement of the wind. So let's say that the wind is moving this way. Okay. Now the thrust doesn't have to be the kite actually moving. The kite could be moving relative to the things around it. So if I was stationary and everything around me was moving, like the world around me was moving, it would look like I was moving and everything else was stationary. Does that sort of make sense? So, in the case here, let's pretend like the kite really is stationary. This is it's gotten up to here and it's stopped. It's not moving at all. But the wind is all moving past it. The wind is going uh, past it, over it, around it, and the person down here is using a force, pushing that way, pulling that way, to hold the kite where it is. So, in essence, relative to everything around it, like all of the air is moving beyond it. So, all the air is moving over it, under it, around it, pushing through it. And the world around the kite is moving, but the kite is not moving. So, what's keeping the kite from moving? This person right here is keeping the kite from moving. So, the thrust comes into, like, if you pretend, like, think in your mind, like, what if the air was not moving and this person down here was just running like the Dickens, really hard that way, you would have the same effect as if this person is just able to hold the kite stationary while all of the wind goes past it. So, in essence, the thrust only comes from one place, no matter what you're talking about. Either the thrust comes from the person, like winding up or holding on or running this way, let's say, so their actual physical movement is pulling the kite and creating thrust, creating a force that is pushing the kite this way. Or there's a relative thrust or a net sort of thrust, which is just holding it and not letting the kite go the way the whole rest of the world around it wants to go, is also a thrust. It's sort of, you can see it, I think, better in water. If you're in a boat that's moving fairly rapidly through the water and you put your hand in the water, it takes force to keep that from going back. The same thing is true in a car. When a car is going, let's say a car is going 50, 60, 70 miles an hour down the road, you put the window down, put your arm out, it takes a force that essentially is thrust to keep your arm from staying back, like going backwards from all that wind. So it takes a force to keep your arm steady with the rest of the world around it. So the thrust here comes from the person either running, usually that's to get started, or if there's a low spot in the wind where the wind dies down, you may have to keep running to get thrust for your kite. The other idea is what happens if what happens when the wind is strong and you're just holding it? Well, there's a force there. You are pushing against the ground and holding the kite, and those forces are actually thrusting the kite that way, just like when you're running. But now the world around it, the air around it, is pushing the other way. So those are where your thrust comes from. So a kite ultimately is like, it's human powered, right? We're either holding it and keeping it from blowing away and just going with the wind, that's accelerating it towards us, or we're actually running with it or walking with it or something, like running with it, or maybe winding it up really fast to keep the kite moving and giving it thrust that way. So those are the two places where we get thrust in a kite. Let's go.